Okay, so this is a bit of an RFID reader project I've been working on. It's communicates over Bluetooth low energy to your smartphone to be able to scan these little RFID tags. These are the sort of tags that you would put into the ear of a cow or a sheep or a goat or something to be able to help you keep track of your herd. And the general idea is that you point this end at the animal or at their tag, push the button, and it scans. I've got a little power switch in the back. And so this would pair with your smartphone to be able to read things. So this is really just a prototype. A friend of mine built the case. Actually, my landlord. He's a retired industrial engineer, industrial designer. He doesn't consider himself an engineer. Rick Meyerchalk is his name. And he does amazing work. This is a PVC pipe. This is PVC siding that he glued together into a chunk, and then on his lathe he milled it down. He even did these cool little circles along the middle just for fun. This button cap is more PVC siding that he glued into layers and then lathed down into shape. So it's a pretty cool case. And then this is leather, just to give it a nice grip. With some Krylon PVC paint, spray paint, to make it all look nice. So it's a pretty simple design. I don't have everything screwed together. There's a detent screw that goes in down here that I don't have in right now. But this comes out just like this. And so then there is the all the circuitry. That's pretty quiet. That's not supposed to be so quiet. Interesting. I'll get to that in a minute. So what we have here is the antenna. You can sort of see the antenna through there. I can take this apart, but it's kind of a pain in the butt. But in here is an induction coil. RFID both transmits and receives through power provided from the device. This is a relay. This relay cuts in and out this tuning capacitor. The tuning capacitor changes the transmission frequency that the device is able to work with. So we can support both 125 kilohertz and 134 kilohertz RFID tags. This is a RFID application board from Priority One Design out of Australia, and basically it handles all of the RFID decoding and converts it into a serial stream. This is the Adafruit Feather M0, and it's got a Bluetooth low energy chip on it. It's got onboard UART support, so I'm able to just wire that up directly to the RFID reader and get the data across as just strings. This is the control button, and the way I have it set up, it sends a command to the board to turn on the radio. So normally the antenna is uncharged. It's not charged, so it won't transmit or receive. Pressing the button sends the command to the RFID reader to turn on that antenna, and then releasing it sends the command to turn it off. 4 AA batteries, so this is running at 6 volts. It's because this thing wants 5 volts. This is 3.3 logic level, so I feed the batteries into the voltage regulator for the microcontroller, and then I power the RFID reader off of the what's called the USB pin on the microcontroller. And that's so that I can, when I switch the power off, I can plug in a USB cable, be able to program this, and still be able to run all of the bits. I'm a little confused why this is so quiet. There's a speaker here and a vibrating motor here for feedback. And I probably need to put some sort of amplifier in here. But you can see the speaker and the vibrating motor. This is just a test program right now for looping through the different feedback patterns that I have. But that's about it. That's my RFID reader. And yeah, I'd show you the Bluetooth side of it, but I mean, it's just numbers on a screen. It doesn't really matter. Yeah, that's it.